Solve the equation d2x dt squared minus 3dx dt plus 2x equals to 2 exponent 3t, given that at t equals to 0, x equals to 5 and dx dt equals to 7. Solution. So as we want to solve this equation by the use of Laplace transforms. So the first thing is for us to get the Laplace transform of this equation. So we start with getting the Laplace transform of this. So Laplace transform of d2x dt squared, this one equals to s squared x bar minus s x naught minus x1. Then we also get the Laplace transform of dx dt, the Laplace transform of dx dt, this equals to s x bar minus x naught. We get the Laplace transform of x, Laplace transform of x, this will be equal to x bar, and then we get the Laplace transform of exponent 3t, the Laplace transform of t of 2 exponent 3t, this will be equal to 2 over s minus 3. So we can now rearrange the equation. I will now rearrange this equation in the Laplace transform. So we shall have this s squared x bar minus s x naught minus x1, then minus 3 minus 3 into, now the Laplace transform of dx dt, which is this one, sx bar minus x naught, then we have the Laplace transform of x is x bar, therefore we have plus 2x bar equals to, the Laplace transform of this is 2 over s minus 3. Now, so after writing the equation, we can open the bracket here so that we have s squared x bar minus s x naught minus x1 minus, open the bracket, it will be 3 sx bar, then this negative and negative will be positive, plus 3x naught plus 2x bar equals to 2 all over s minus 3. Now after we have written the equation, the Laplace transform, we now insert in the initial conditions. We said that at t equals to 0, x equals to 5 and dx dt equals to 7. So our x equals to 5 is our x naught. So where there is x naught, we replace with the 5, and x1 is 7. Dx dt is our x1. Therefore, when we substitute this one, the equation becomes s squared x bar minus this was sx naught. Now our x naught is 5. So here we remain with the 5. With the 5s minus x1 is 7, like that, then minus 3s x bar, then x naught is 5, so this will be plus 15, then plus 2x bar equals to 2 all over s minus 3. How do we have like terms? Of course, we have we shall group those that have, we shall group this one to be together so that we can have s squared minus 3s, then plus 2, then we factorize out x bar, then minus, so this one equals to all the remaining others crosses equal sign, so we have 2 over s minus 3 plus 5s, then we have negative 7 plus 15 will remain with positive 8. When 8 crosses the equal sign, it will be minus 8, like that. Okay, we have s squared minus 3s plus 2 into x bar equals to this. So we can factorize this expression. We have s squared minus 3s plus 2. Two numbers, when we add, we get negative 3. When you multiply, you get positive 2. So the numbers are negative 3, negative 2, and negative 1. Therefore, this is given by s squared minus 2s minus s plus 2. So we factorize. So here we have s into s minus 2. Then we have minus 1 into s minus 2. So we have s minus 1 and then s minus 2. Therefore, we can now make x bar the subject, so that x bar now equals, so we divide both sides by this, so we have 2 over s minus 3, then you have s minus 1, then you have s minus 2, then plus 5s minus 8 over s minus 1, then we have s minus 2. So this equals to, now the LCM of all of this, the LCM will be s minus 3, s minus 1, and then s minus 2. So this goes here how many times? 1. 1 times 2, we have 2, plus s 5s, s minus 1, s minus 2 goes here how many times? S minus 3 times this, so we have plus 5 s minus 8 into s minus 3. So when you open up the bracket here, this will be equal to now 2 plus, so here we have s5, so we have plus 5s squared minus 15s minus 15s minus 40 then plus 24 over s minus 3, s minus 1, then s minus 2. So this equals to, so here we have 5 s squared, this one, then we have minus this is not, this is s, just a minute, we have s 15, this is we get 5s, that's fine, this is 15s, that's fine, this and that 8, this is 8s minus 8s plus 24, so this is 15s minus 15s minus 8s, this comes to minus 23s, minus 23s, then plus 24, so it will be 26 plus these 2, 26 over s minus 3, s minus 1, s minus 2. So this equation, we now get the partial fraction for this equation. So we shall say s 5s squared minus 23s plus 26 over s minus 3, s minus 1, s minus 2. This equals to a over s minus 3 plus b over s minus 1 plus c all over s minus 2. Every single every linear factor in the denominator gives rise to a partial fractions. So we multiply through by this common denominator. So when we multiply on this side, this will cancel that, so we remain with 5. We remain with 5s squared minus 23s plus 26 equals to, so here we have a into, we shall have s minus 1, s minus 2, then plus b into s minus 3, s minus 2, then plus c into s minus 1, s minus 3. So from here we can use the curve up rule. Put, now we have s minus 1, I have s minus 1, so if I want to eliminate this fraction and this one, I will put s equals to 1. Therefore, if this is 1, 1 minus 1, 0, this will be 0, 1 minus 1, this one will be 0, then I remain with the b alone. So when I put s equals to 1, the equation becomes 5, 1 squared is 1, so here I remain with 5, minus 23, because this is 1, plus 26, this equals to, this is 1, 1 minus negative 2, negative 2, this is 1, minus negative 2, negative 1, this is 2 times the b, so I have 2b. So 26 minus 23, I remain with 3, 3 plus 5, I have 8, equals to 2b. Therefore, b equals to 8 all over 2, which is equals to 4. So if I want to get the value of if I want to do away this bracket and this one, so that I get the value of a, I'll put s equals to, here I have 3, put s equals to 3. So if this 3 to be 3 minus 3, this will be 0, 3 minus 3, this will be 0, so I remain with this. So when I put s equals to 3, so here I'll have now this is 3 squared 9 times 5, I have 45, then minus 23 times 3, 23 times 3, this is 9, have 69, so I have minus 69, then plus 26, this one equals to, so this and this will be 0, so I remain with this is 3, 3 minus 1, I have 2 here, and then 3 minus 1, I have 1, 1 times 2, 2 times a, I have 2a. So 26 plus 45, 26, 45, 11, carry 1, 71. So we have 71 minus 69. 71 minus 69 is equals to 2a. 71 minus 69, this is 2 equals to 2a. Therefore, a equals to 2 all over 2, which is equals to 1. So here we are saying that a equals to 1, b equals to 4. Now we want to get the value of c. We want to get the value of c. So how do I get the value of c? You can see you have s minus 2, I have s minus 2 here. Therefore, to get the value of c, I will eliminate this bracket and eliminate this bracket by letting s equals to 2. So we put s equals to 2. So if I put s equals to 2 here, I have 2 it will be 4. 2 squared 4 times 5, I have 20. 20 equals 20 minus, so this is 2 times negative 23, I have negative 46 plus 26 equals to, so this and this will be 0, then I remain with, so s is 2, 2 minus 1, I remain with the 1, and then I have s, which is 2 minus 3, I have negative 1, times 1, I have negative 1 times s, so I have negative c, so this equals negative c, so 46. So you have 26 plus 20, I have 46, minus 46 equals to 0, equals to negative c. So c equals to 0. C equals to 0. Therefore, from here, our equation now, and remember this was our x bar. Therefore, we are saying that x bar equals to a is 1 over s minus 3 plus b is 4 over s minus 1, z is 0, therefore this is 0. Therefore, this is what we have. To get the value of x, we get the inverse Laplace transform of this equation. The inverse of x bar equals to the inverse of 1 all over s minus 3 plus 4 over s minus 1. So the inverse Laplace transform of x bar will be x, which equals to the inverse of this is exponent 3t plus this will be 4 exponent t, and this is the result of this expression. So when you solve this equation, d2x dt squared minus 3 dx dt plus 2x equals to this, the result will be x equals to exponent 3t plus 4 exponent t. Thank you for watching.